Hello, today we will be looking at rates of change and behavior of graphs. So these notes correspond with the free college algebra textbook at openstacks.org. It corresponds to section 3.3. So if you have questions or want more information, please go to the website. The address is listed at the bottom of the page and see what they say in the book. So the first part we're going to look at is finding an average rate of change given a function and an interval. So for number one, we want to find the average rate of change for f of x on the interval -2, 4. So if you remember from the lines, a linear equation, you have a slope. And the slope is the rate of change for a line. We call it here, instead of a slope, we call it a rate of change because it's not necessarily a slope. It doesn't have the same value increasing or decreasing throughout the entire graph. So it's just a rate of change, and it's an average rate of change for these two specified endpoints in your interval. So for number one, it's a quadratic equation. This is going to change. Their average rate of change will change depending on the endpoints you've chosen for your interval. So keep that in mind. It's not like a line where it's the same no matter what points you choose. If you don't have a linear equation and you have some other equation, the average rate of change is going to be different based on the interval chosen. So that being said, let's do some examples. So for number one, we want to figure out what this is going to be. So the way you find an average rate of change is you're going to have the y values, and remember the y values are the same as the function value, and you take the difference of that and you divide it by the difference of the x values. So for example, I could say f of b minus f of a over b minus a, and that will be the average rate of change. So in order to find that, we first need to find the function values, the two endpoints. So first we'll find f of 4, which means we're going to plug 4 in everywhere we see an x. So then we get 5 minus 2 times 16, 4 squared is 16. 2 times 16 is 32. And then 5 minus 32 is -27. So that is f of 4. f of 4 is -27. Now we're going to find f of -2. So I am just taking these points right here, these endpoints on my interval, and plugging them in. So f of -2, we're going to have 5 minus 2 times -2 squared. So that will be 5 minus 2 times 4, which will be 5 minus 8, which will be -3. All right, so for each of these, I have an ordered pair. The x value was 4. This is the x value, and this is the y value. This is the x value. This is the y value. So I'm going to simply subtract using my formula. So I'm going to have the y values, or the function values, on top. So -27 minus -3 over the corresponding x values, 4 minus a -2. Now notice the numbers that go together are on top of each other. So for example, -27 and 4 go together. That's an ordered pair. Notice that they are lined up on top of each other on the fraction. That should always happen. Here we have -2 and -3 that go together as an ordered pair. Those are lined up over each other in the fraction. So that should always happen. The order doesn't matter. You could have put the -3 first on the top, but if you put the -3 first on the top, you have to put the -2 first on the bottom. Okay, so let's see. -27 minus a -3, that's going to become plus a positive, and the same on the bottom. So -27 plus 3 is -24, over 4 plus 2 is 6, and when we divide that out, we get -4. So the average rate of change is -4. So quite a few things go into getting the average rate of change. You have to find each function value for the endpoints, and then use the formula, simplify the fraction. That gives you the average rate of change. All right, so let's try the next one, number 2. So we want to have f of 5 is equal to 3 times 5 minus 4, which is 15 minus 4, which is 11. And then we have f of 1 is going to be 3 times 1 minus 4, which is 3 minus 4, which is negative 1. And so now we're going to use the formula. So we'll have 11 minus a negative 1 over 5 minus 1. So that's going to be 11 plus 1, right? These two negatives make a plus. So that'll be 12 over 5 minus 1 is 4. 12 divided by 4 is 3. So the average rate of change is 3. All right, so let's look at number 3. So for number 3, we're going to do the same thing. Notice here I have an H, so I don't have two numbers. So if I'm using a variable, I'm probably going to end up with some expression at the end rather than just a number. So I'm going to find g of h. That's going to be 2h squared minus 9. And now I'm going to find g of 4. So that's going to be 2 times 4 squared minus 9, which is 2 times 16 minus 9, which is 32 minus 9, which is 23. Okay, so now I want to use my formula. So I'm going to have 2h squared minus 9 minus 23 all over h minus 4. Okay, so I have like terms on the top, so 2h squared, it's going to be minus 32 over h minus 4. Now you need to try to factor. So the bottom, since I don't have an exponent on the variable, it's fine. But the top, I want to try to factor that. The first thing I notice is that there is a greatest common factor. So I'm going to take out a 2, and that'll leave me h squared minus 16. And now h squared minus 16, that's a difference of squares. So I'm going to factor that into h plus 4 and h minus 4. And look what happens. The h minus 4s are going to cancel out. I have one on the bottom and one on the top. So that's going to leave me 2 times h plus 4, or you can give it as 2h plus 8. That will be your average rate of change on the interval 4h. So again, since we had an h to plug in, we're going to get an expression. Usually that's what happens. Okay, so that's finding a rate of change given a function and an interval. The next 3 are going to be finding difference quotients. This is still an average rate of change. It's just a special one. So here is your formula that you're going to use. You should have this formula memorized in case it's not given to you. So it's f of x plus h minus f of x over h. So we have 3 parts here. So let's look at the 3 parts. The first part is the f of x minus h. The second part is the f of x. And the third part is this constant h. You're given the f of x. F of x is given right here. So for f of x, you can plug in this. This is what's going to be plugged in to f of x. Now we need to find f of x plus h, the red. We do not have that, but we can find it if we plug in x plus h everywhere where there's an x in the given function. So 3 times x plus h minus 2. So we distribute the 3 and we get 3x plus 3h minus 2. There are no like terms, so that's it. So f of x plus h is going to be this function right here. So that's going to go in for the red, the f of x plus h. And then h just simply stays h. So I'm going to plug that in. So the red is 3x plus 3h minus 2. Okay, and then minus f of x is 3x minus 2 over h just as h. Okay, and so now it's just a matter of simplifying this fraction. So I'm going to distribute this negative. So that's going to give me 3x plus 3h minus 2 minus 3x plus 2 all over h. And now look what happens. Your 3x and your negative 3x cancel. Your negative 2 and your positive 2 cancel. And that just leaves you with 3h over h. Now your h's cancel. And so that just leaves you with 3. So your difference quotient is simply 3. Okay, so here are the steps. Again, the first step is to find f of x plus h, which we did in the red. Then you're going to plug in all your pieces in the fraction. So the red gets plugged in f of x plus h minus f of x, which is the blue, all over h. And then it's a matter of combining like terms on the top, canceling things out, and then simplifying. Okay, so we're going to do the same thing with number 5. So with number 5, we first want to find f of x plus h. So we're going to get 4 times x plus h cubed. Okay, so now we're going to have to do some work to get this all factored or distributed out. So this is x plus h cubed. Okay. So I'm going to go over here and do some scratch work. Okay. X plus h cubed is the same as x plus h times x plus h times x plus h. So we're going to start with just 2 of them. So you can only multiply 2 at a time. So we're going to do these 2, and then we'll come back and multiply the third one. So this is going to give me x squared plus xh plus xh plus h squared. So that'll be x squared plus 2xh plus h squared. So that's the first 2. I still have to multiply it by this third x plus h. So now that will be, let's see, x squared plus x is x cubed. X squared plus h is plus hx squared. So I've distributed that one. Now I need to do 2xh times x is plus 2hx squared. 2xh times h is plus 2h squared x. That one's done. Now h squared times x is plus h squared x. And h squared times h is plus h cubed. Okay, so that's a lot. We've got to take all of that and put that in for the first one. But wait, also, wasn't it multiplied by something, like a 4? Yes. So we got 4 times all of that. So that's going to change. So we've got to multiply 4 times all of that in green. So that'll be 4x cubed plus 4hx squared plus 8h squared. Okay. So we did that one, that one, that one. Plus 8h squared x plus 4h squared x plus 4h cubed. Okay, I'm going to have to erase some of this stuff. But I think we have all of that now. So let us erase all of this. So you're going to have to make sure you have plenty of space to do your side work. Okay. Now that's a cubed. Okay, so let's look and see if we have any like terms. So we have h x squared and hx squared. So that's going to be 4x cubed plus 12hx squared. And then we have h squared x and h squared x. So plus 12h squared x. And then plus 4h cubed. Okay, so now that is what we want to use for f of x plus h. We're going to subtract that from, or we're going to subtract f of x from that and then divide by h. Okay, so let's see. For now, I'm going to cross this one out, so we're just going to keep working down. Okay, so we're going to have f of x in red. So we're going to have 4x cubed plus 12hx squared plus 12h squared x plus 4h cubed, so f of x plus h, minus f of x. F of x is 4x cubed all over h. Okay, so now our job is to simplify. So this minus just gets distributed to this one term. So we're going to have 4x cubed plus 12hx squared plus 12h squared x plus 4h cubed minus 4x cubed all over h. And we can see that our 4x cubed and our negative 4x cubed are opposites, so those cancel. So now we have 12hx squared plus 12h squared x plus 4h cubed all over h. And look at what happens. We have an h in every single term on the top. So we can divide out an h from each term. So that'll leave us 12x squared plus 12hx plus 4h squared. None of those are like terms, so that is as far as we can take it. So that is our difference quotient for 4x cubed. If you're not quite finished writing, go ahead and pause this and finish. I'm going to erase this so we can do number 6. So let's look at number 6. All right, so number 6, same thing. We're going to do the difference quotient. So the first thing we want to do is find f of x plus h. So f of x plus h is equal to 2 times x plus h squared minus 3 times x plus h plus 1. So we're going to start by foiling out the x plus h squared. So we're going to distribute that. Remember that that is like x plus h times x plus h. And so when you do that, you get x squared plus xh plus xh plus h squared. So x squared plus 2xh plus h squared. And then we've got to multiply that all by 2. So we're going to have 2x squared plus 4xh plus 2h squared. Then we have to distribute the negative 3. So negative 3x minus 3h plus 1. There are no like terms, so that's my f of x piece. So I'm going to have f of x f of x plus h minus f of x all over h. So we'll have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus f of x, which is 2x squared minus 3x plus 1, all over h. Okay, and so now we're going to distribute this negative to the three terms in blue. And so that'll give us 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. Okay, so now we should be able to do some canceling out. We should always end up with some opposites in the top. So you have 2x squared minus 2x squared. We have a negative 3x and a 3x. And then we have a 1 and a negative 1. So notice each time everything without an everything without an h is canceling out. So we're left with stuff with h's so that we can reduce. Okay, so when we do that, we get 4xh plus 2h squared minus 3h. I think that's all the pieces over h. And again, every term on the top has an h, so we can reduce that, and we get 4x plus 2h minus 3. So that is our difference quotient for that one. All right, so make sure you know the formula and how to do it, regardless of what kind of function you get. Okay, so for the next ones, okay, so for these, we're going to find the average rate of change given a graph for number 7. And so the key here is making sure you know where your points are. So it says the average rate of change from x equals 1 to x equals 3. So when x is 1, that's here, your point associated with that is here. So your ordered pair is 1, 5. Then it says x equals 3. Whoops. X equals 3 is here. So here's your point associated with that. And so your ordered pair for that is 3, 1. So there are your x and your y values. So that's what you're going to use to find your average rate of change. So you're going to have y's, so 5 minus 1 over your x's, 1 minus 3. Okay, and so then that's going to give you 4 over negative 2, which is a negative 2. So your average rate of change on this graph from x equals 1 to x equals 3 is 2. Now, keep in mind that that rate of change would be different if you chose different x values. Okay, it doesn't have to be the same in this case because you can see the rate of change is different. It's decreasing from 1 to 3, but it's increasing from 3 to 5. So the rate of change would clearly be different there because it's going to be a positive instead of a negative. All right, number 8. Here we're going to use the graph to estimate the intervals on which the function is increasing or decreasing, and then we're going to identify the local minimum and local maximum. So a few new verbs, or new words I should say. So a few new words, increasing and decreasing. So what we're going to look for here is we're going to start at the left of the graph, and we're going to follow the graph and see if we're going up or down. So I'm going to start over here at the very left of the graph, and I'm going to go with the graph. And you can see that from here I'm going down, and I'm going to keep going down until right here. This is where I stop going down. Then if I want to keep following it, I'm going to be going up. So that's increasing, and I'm going to keep going up until I get to this peak right here, at which point it starts to go down again. So that's decreasing, okay? So the yellow is decreasing and the green is increasing. Those are the intervals on which the graph is increasing and decreasing. You always start from the left and move toward the right and see if you're going up or down. So from there, I can write my intervals on which it's increasing and decreasing. So the graph is decreasing in yellow. So that is, here's another thing. When you're doing increasing and decreasing, you're looking for the x values. So similar to your domain, you're only looking at the x values. So left to right. It starts decreasing at negative infinity, and it continues to decrease until we are right here, which it looks like is about a negative 1.5. So we're going to put negative 1.5, or you could put negative 3/2. Okay. And for increasing and decreasing, you always use parentheses. You never use a bracket, because it's not increasing or decreasing at one particular point. It's increasing or decreasing over the interval. So never use brackets. All right, and then it's decreasing again, starting here, which is at 2. So the x value 2, and it continues decreasing to the right to positive infinity. Right, to the right is positive infinity. Okay, it's increasing on the green interval. And let's see, it starts increasing here at negative 1.5. And it stops increasing here at 2. All right, so there is where it's increasing and decreasing. The next thing we're looking for is a local minimum and a local maximum. So this is a minimum value in a certain area. So wherever it changes direction, for example, it changes direction here, right? It goes from decreasing to increasing right here. There is going to be a minimum, because it's at the bottom, located at this point. There's going to be a maximum, a local maximum here at this point. That doesn't mean that that's the lowest value of the entire graph. It's not, because this continues to go down to negative infinity. And this local maximum is the maximum in this area where it changes direction, but it's not the maximum of the entire graph, because it continues to go up. But a local min or a local max is the highest point it gets in that area, okay, or the lowest point it gets in a certain area. So we're going to have a local minimum. The local minimum is right here, because that's a bottom point. And let me erase all my scribblings and highlightings here so we can kind of get a better idea for where this is. All right. So the local minimum when x equals 1.5, negative 1.5, is, it's really close to negative 3, right? So maybe we could put negative 2.9. So the local minimum is negative 2.9. So the actual, when you're telling the local minimum or the local maximum, it's the y value. You can say it happens when x is negative 1.5, but the actual value is negative 2.9. And then the local maximum that happens up here when x is 2. It looks like the y value is above the 4, so let's say 4.2. And clearly I'm having to estimate because it's not exactly at a number, but that's fine. If you're pretty close, that'll be good. Okay, so the local minimum is 2.9, and the local maximum is 4.2. Okay, so local min and local max is just the local minimum or maximum value that it reaches around a certain value. If we look at the previous example, just to pick out some local max and local min values, this would be a local max because it's a high value up here. This would be a local minimum. So this local max would be a local max of 5. This would be a local min of 1. This would be another local max, so another local maximum of 7. And this would be a local minimum of 3. So there could be more than one of each one. Okay, let's look at number 9. So number 9, we're going to use the graph to estimate the intervals on which the function is increasing or decreasing, and then we're going to find the value of the absolute minimum. So that's different. The previous ones we found were the local min and local max. This is the absolute minimum, which means it is the absolute lowest point on the graph. Okay, and you can see from this, it's also a local, right? This is also a local minimum. This is a local minimum. But it's also the absolute minimum, because at no point does it ever get lower than this point. So this is an absolute minimum. So the absolute minimum, since I started talking about that, I'll go ahead and write that now. The absolute minimum is -3. So again, you're looking for the y value. That happens when x equals 1. The absolute minimum value is -3. Okay? Now let's follow the graph and see where it's increasing and decreasing. So if I start on the left and I follow the graph, hopefully you can see that I am decreasing. And I decrease until I get to that absolute minimum. So my decreasing is going to start at -infinity, because it goes to the left forever, and it continues to go to the right until I get to 1. Remember, increasing and decreasing, you're looking at the x values. And then at the absolute minimum, it changes direction, and I start increasing, and I'm going to increase forever to the right. So the increasing, it would start at 1, and from 1 to infinity, it's increasing. And that's all it asked us to do there. All right, the last one, number 10, we've got an application problem. A driver of a car stopped at a gas station to fill up his gas tank. He looked at his watch, and the time read exactly 3:40 p.m. At this time, he started pumping gas into the tank. At exactly 3:44 p.m., the tank was full, and he noticed that he had pumped 10 gallons. What is the average rate of flow of the gasoline into the gas tank? So we want to know the rate of flow. So how many gallons per, let's say, minute, because that's what we're looking at, right? There's 4 minutes. So how many gallons per minute? So he started and he pumped exactly 10 gallons. So if we're doing gallons per minute, that means gallons are going to be on the top and the minutes are going to be on the bottom. How many gallons did he pump over that time? 10. How many minutes did he spend? Well, you subtract and you get 4. So 10 divided by 4, that's 5 halves. If you want to write it as a decimal, which they often do in these rate problems, that would be 2.5. So 2.5 gallons per minute is the average rate of flow. This is just an average rate of change. It's how many gallons are changing over the minutes. The formula we used is he pumped 10 gallons from 10 minus 0, assuming he was empty, and he pumped that over 4 minutes, right? Because 344 minus 340. Okay, that brings us to the end of this section.